Hi, I'm Stefan.
Hi, I am also Stefan. Welcome to Austria,
where we are storing hydrogen underground.
Imagine using a reservoir more than 1,000 meters below the surface to stabilize the energy system. Rag Austria are doing exactly that, using a porous sandstone reservoir where natural gas was formed millions of years ago to now store green hydrogen when demand rises. This hydrogen travels 8 kilometers to a combined heat and power plant where it's converted back into electricity and heat. We visited their facilities near Gampern to see how this seasonal energy storage solution can make intermittent renewables more reliable.
Stefan, thank you for welcoming Enlit on the road to Austria. What is it about this project that's so unique?
Here we can store a really large amount of hydrogen over the seasons. That means over months and even years. And then to use the hydrogen, which is produced from solar energy in summer, when we need it in winter times.
You can access it at any time. That, I can imagine, really helps with system resilience. Can the system be grid dispatchable, responding dynamically to fluctuations in power demand?
So here at Rag Austria, the installation supplies the facility from Rag Austria with electrical power and heat. But yes, when we are scaling it up with higher capacities and with multiple engines, the produced energy can be supplied to the grid and the heat can be used for district heating.
And when it comes to extreme conditions, let's say incredibly low levels of renewable power or extreme cold or even power outages, how does the system perform?
So this installation here is a dual fuel engine, means that if there is no hydrogen available, the system can be supplied with natural gas from the pipeline. So it can always produce heat and power. And as well, if there is only a mixture available, it can also produce safely energy. Here, one of the specialities is that the engine can run also on not clean or not pure H2, which is a big advantage, especially for this kind of installations where hydrogen is stored in a porous sandstone reservoir.
As an operator, what are your key concerns and how does hydrogen help resolve that?
The main points are to reduce the CO2 emission, and the second point is to calculate the costs for energy. When we have hydrogen for the energy, we can calculate it for a long time, not day by day. The big advantages for hydrogen is to can store it for a long time and in big volumes. The Rubensdorf storage was chosen because it's ideal location nearby to the Rag infrastructure and its relatively small size. This made it possible for the demonstration project to build the facility at the calculated cost and could serve as a blueprint for further scaled project.
We're standing on top of the hydrogen. How do you get that from here to the CHP plant and then to the end user?
So the hydrogen gets produced via an electrolyzer. Into that process, the hydrogen gets produced already with a certain pressure, and this gets then stored in the reservoir more than 1,000 meters below to us. When the demand is there, the valves can be opened and the energy can flow. In that case, the energy will flow to the CHP power plant, and then it gets transformed from H2 to electricity and to heat.
Is there a way to use existing natural gas infrastructure for hydrogen storage?
Yes, we think there is so. You cannot use all the infrastructure, but the main points like pipelines, you can use the reservoir, you can use the valve, but you don't use the compressors or drying units.
How does Rubensdorf act as a blueprint for replicating this type of technology?
Rubensdorf give us the first information, the first experience to operate like a storage with hydrogen, we need this information to scale it up in bigger facilities. We have project for bigger facilities.
15 years into the future, what does success from Rubensdorf look like?
I think in 15 years we have 2-3 big facilities to storage hydrogen here. For example, here for 14 years, we have built up the first natural gas storage facility. 10, 15 years later, you build a bigger one, and this grows. We think the same with hydrogen.
What are the response times like? How long does it take to go from on standby hydrogen to actual heat and power?
Gas engines have very rapid starting times. In this project here, we have starting times under 300 seconds. Depends on the customer requirements, and as well for the application they need it, the system can completely customize for that.
How does this project actually move the needle for Europe's energy transition though?
So together with Rag Austria, we are showcasing how decarbonization can be advanced, and as well the reliability of a green energy future can be turned into real life. Also to convert natural gas storage systems, as well also CHP systems from natural gas to hydrogen.
You talk about scaling up. What would be some of the considerations for that into the future?
So I think we've proven that the system is working. That means the technology is here, so we can use it. So we need strong partners that they are also ready to move, and they are moving, and they want to change the energy future in green.
Stefan, thank you so much for your insights. For more insights, join the Enlit community.